Hello, ladies and gentlemen. This is Mr. Briggs. I'm teaching you today lesson 2.4, measures of center and shapes of distributions from data distributions. The classwork is on page 40 through 43, and your ACE problems are 7 through 12 and 18 through 19. All of these are located. They're actually the last lesson we're going to do in this book. So congratulations. After this, we'll be done with 7th grade math and on to 8th. Let's go ahead and get started. All right. First thing, shapes in data. We have a question here, and the question is, what happens when the median and the mode are different values? Remember that the mean is the center value, and that it can be thrown off by outliers. We can have a number that's way off one way or way off in another, and it will completely throw off our data. And this is, and the median, remember, has to do with numerical data, that we're finding sometimes a fraction. Sometimes it's going to be thrown off one way or another. And the median, on the other hand, tells us that half of the values are above this, half of the values are below this. That this is the center of our data if we arranged it in order. Okay? So what happens here? For instance, we have the serial again. Again with the serial. Well, the mean is located at 4.5. And that means that we have some serials here, namely this one that is 10 these two that are 10 grams here, and these three over here that are 11 grams, that are throwing off our data. A majority of our numbers, most of our values, we find are going to be around 3 or 2 or 1 or even 0 grams of sugar per serving. We notice that a lot of these values are down here, that only this relative few are so way off the charts in this one direction that they are throwing off our data. So in this case, it tells us that while the value of our serial, right, might be closer to 4.5 if we were to average these out, that if we were to look at the number of serials, we would find most of them being clustered around 3. Okay? So, another thing to talk about is how data is distributed, how it's shaped. For instance, we normally want data, if it's averaged, to look like this, a bell curve. Yeah, this one it's labeled as normal, but it's called a bell curve. And what that tells us is that we have most of our data occurring here in the middle, and that we have a few on either side, and that it will look like a general bell curve, that we have a nice set average and half of them are below and half of them are above. In this case, our median and our mode usually are the same. Okay? Now, the median and the mean are the same. However, we sometimes get something like this where it's rectangular. And rectangular occurs when you've got the data evenly distributed across the range. Things look flat. That we have the same number on the low end as we do on the high end, and everything tends to be well represented across our data. And then finally, we have the positive skew and the negative skew. And basically what these mean is when something is skewed, it means it's leaning one way or it's leaning another. So, for instance, if we have a lot of values on the low end of the scale or a lot of values on the high end of the scale, it tells us that a lot of people, like let's say if they were taking a test, would be doing really well on the test or really poorly on the test. Most of the time, us teachers would like the tests to be here on the bell curve, with most of us getting B's or C's, a few people getting A's, a few people getting F's. If it looks like one of these guys, though, it's not so good. All right. Your lesson takes place on classwork page 40 through 43, then do 7 through 12, and then 18 through 19. Have fun.